Hello everyone, my name is Chonradee Amnatsin and today I'm going to present about the study of selectivity of metal oxide gas sensor to ketone group. So first, what is ketone group? Ketone is the one chemical functional group that has structure look like this. The example of ketone group solvents is acetone, methyl ethyl ketone or MEK, and methyl isobutyl ketone. Ketone solvents has been used in many applications such as nail polish, pharmaceutical, and cosmetic. So what is the danger of ketone solvents? In short term, acetone at concentration 100 to 900 ppm, it can cause eye and respiratory irritation and also the throat irritation. And at 12,000 ppm, exposed for only 2 to 3 minutes, it can cause nausea. So to detect this gas sensor is used to detect. So there are many types of gas sensor, but in this slide is the most used type of gas sensor. And the first one is electrochemical. This one is sensitive, stable, but it's expensive. Electrochemical gas sensor is operated by the current that produced from chemical reaction inside the gas sensor. Next one is metal oxide gas sensor. It's very sensitive. It's more stable with high humidity, and it has medium price. It's operated by change of resistivity. And the last type is catalyst gas sensor. Catalyst gas sensor has poor sensitive, very low stability, but it's cheap. This type, it can only detect the flammable gas because it uses the combustion inside the gas sensor. And in my work, I will be focused on the metal oxide gas sensor due to the stable in high humidity environment. But metal oxide gas sensor also has the disadvantage because it has wide range of gas that it can detect, or it can detect more than one type of gas. But I will be discussed later on. So the structure of metal oxide gas sensor is shown in the left picture. Inside the gas sensor, at the bottom, it will have a heater and the substrate and electrode left and right. And on top, it will have sensing material, which is metal oxide layer. Then when it connects to the electricity, the electron will flow from one electrode to another electrode, as shown here. And when it's exposed to air, oxygen in the air will be absorbed on the metal oxide layer surface, and the oxygen will couple with the free electron inside the metal oxide layer and causing the change in electron that flow pass through the layer. And then once it exposed with the target gas will react with the oxygen and it will pull the oxygen out, causing the change in electron that flow inside the layer. And as shown in resistance over time, then first, with no target gas, the resistance of the sensor will be constant and stable. And once the target gas comes in, the resistance will start to drop and constant for a while. And then when the target gas is out, the resistance of the sensor will be recovered to its initial level. So gas sensor has been used for many purpose. It's used in factory safety, used for medical application, used for food industry, using LPG sensor in our house, and also at the police alcohol check station. In my work, I will be focusing on the factory safety. And for the literature review, I review about the factor that can affect the selectivity and the sensitivity of the sensor. Then I found out that there are two main parts of the factor that can affect. First is the production factor. The second is environment factor. The production factor is a type of metal oxide that's used to produce the gas sensor, the dopant material, the operating temperature, or the temperature of the heater, and the structure of the metal oxide film and the thicknesses of the film. For the environment factor is the humidity in the environment. And in my work, I will be focusing on the humidity, how humidity affects to the sensor. So, how humidity affects to the sensor? At the A picture here, you can see that the orange sphere one is the oxygen that absorbed on the surface of the metal oxide gas sensor. But in the B picture, you can see that once the humidity is high, it will take place on the oxygen place. It means that it has lower position for target gas to contact with the oxygen. And at this graph, you can see that at the high humidity environment, it will have the lower response than the dry air environment. Then come to my research questions that does humidity really affect the response of the sensor, and that the sensor respond to different solvent in the same functional group differently. And this picture is the data sheet of the sensor from the company that I bought the sensor from. As I told you earlier, that one sensor can sense many types of gas, and I wonder that does it sense the gas in the same functional group differently, or is the same? And my objective is to study for choosing the best sensor for solvent and ketone group, and to study the selectivity of metal oxide gas sensor to specific solvents such as acetone and MEK. Outline of my work is first test the sensitivity with the acetone and MEK to find the best and worst sensor at concentration 50, 100, and 1000 ppm. And two, test the selectivity of the sensor by using the mixing gas. And three, study the effect of around 750 to 1000 per 8 hour. And for MEK is 200. And I choose to test it in the range of 50 to 1000 ppm. And this is my experiment setup. I use the desiccator chamber. At the lid of the chamber, we have different commercial sensor, 19 sensors inside of the chamber. And then this sensor will connect it with an Arduino board. And then the Arduino board will be sending the signal to the computer. And this is the sensor list that I used. And from the information that I've got from the company, I expected that these two sensors will be the best sensor for acetone and MEK detection. My methodology: first, I calibrate the machine for 30 minutes to obtain the constant R, and let the time for the heater to heat to the operated temperature. Then I run a program and inject the solution with the side rings at the top of the desiccator here, and then I measure the resistance change for 10 minutes, and then I unwrap it and clean the chamber. This one is the raw data that I've got from the program. The R0 is the R before inject the gas, and RS is R after inject the gas. And I use this to plot the R ratio graph and finding the best and worst sensor by using the value of R ratio. The one that has lower R ratio will be the best one, and the one that has high R ratio will be the worst one. And then result and discussion. This is my result for acetone. The one that sense acetone best or has lowest R ratio is this one, and the second is this one, third is MQ3, this one, and the one that worse in acetone detection is this one. And from this, I compare the graph of top 3 sensors for acetone detection. And as you can see here, at the first two, it's showing the high sensitivity to ketone group, because for methanol and ethanol, it shows the R ratio like very high, almost close to the air. And for the third one, there are no difference between acetone or MEK and ethanol and methanol. And for MEK, the best one is also this one, and the second place is this one. These two are the top 2 of acetone also, and the third one for MEK detection is this one, which is different from acetone. And the worst sensor for MEK detection is SP155A here. And compare the top 3 sensors. Top 2, they are very sensitive to ketone group. But in the third place, the response of acetone MEK compared with methanol and ethanol, it's very similar. And then I compared the response of the top 2 sensors that are the top 2 in both acetone and MEK to see that does it has the different in terms of the response. And as we can see here, it can sense MEK better than the acetone in both sensor. But in Tg2602 is more separate of the R ratio, but not that different. And for the worst sensor that sense worse in acetone and MEK, both, we can see that the R ratio is very high, almost like the air. Like it means that for SP15A00, it barely sense both acetone and MEK. And for a conclusion, the sensor that sense best for acetone and MEK is TG826 and TG2602. The worst sensor for acetone detection is SP36100, and for MEK is SP15A00. And from the experiment, it can be concluded that the response of the acetone and MEK are different in the same sensor, and it can also be used as the industrial safety applications because it can detect in the low limit range. And my future plan is to test with another solvent in ketone group and test with mixed gas to see the selectivity, and then redo the test again, and then find a way to identify the gas in the system. Thank you for your attention.